So let's go ahead and grab something out of the book. And while I'm picking a problem out of the book, could the control room turn off the back monitor up there that's got some kind of other tennis match or something going on, and it's distracting me. Okay. Okay. I'm glad it's in the back of the room, otherwise all you folks would be watching the tennis match or something, or whatever it is. Okay, let's start with let's take this problem, and I'm going to go ahead and throw it up on the computer screen here, or on and I'm going to bring it in so people can see it. Look at this question where my fingers are, number 36.
What page are you on?
I'm over on 266, and I'm going to put my pencil right there so people watching the DVD can see that, and I'll come in even closer. So we're taking a look at this question right here. Always draw a picture if you can. So this particular problem tells us that f of x is given to us as x minus 2 quantity squared. Notice what else they just gave us in the problem. A restricted domain. And then associated with it is g of x equals the square root of x, and outside the square root is a plus 2. Let's draw sketches of each of these first, and then we'll look at what the instructions were for doing the math. If we draw the f of x, and while I'm at it, I'm going to draw the dotted y equals x line, because that seems to be a really critical piece for seeing the connection between a function and its inverse, doesn't it? Drawing that y equals x line. So that means you're probably going to use equal scaling for your x and y on your graph paper. So I'm going to draw a parabola that's shifted 2 to the right. And so normally that parabola would then have its vertex here at 2, 0. And it only wants the right-hand side of it for the domain x greater than or equal to 2. So if I go 1 to the right of that, I should be up 1. And if I go 1 more to the right of that, I should be up 4. Oh, interesting. That looks like that would be a 0.44, wouldn't it? Check that out on the f of x. Is f of 4 equal to 4? Yes. If you check it by putting a 4 in the original function. Okay? 4, 4. Lands right on the y equals x line. And so we have fairly accurate sketch here now, looking like this. Okay, while we're at it, let's draw g of x. And I'm going to go ahead and label this f of x. F of x.
So you don't do the other side of the parabola because it can't be less than 2 anyway.
Yeah, exactly. Yeah, good observation. Only draw what they tell you to. Okay? This is only a portion. This is a perfectly good function. Perfectly good function passes a vertical line test. Notice something else. It also passes a horizontal line test, doesn't it? Everybody listening? This particular thing actually passes also a horizontal line test. Now that's pretty slick, because what happens when we form an inverse? Right? It's going to pass a vertical line test. If this thing passes a horizontal line test and we form its inverse, the inverse will pass a vertical line test, which means that that inverse will be a function. Still awake? Okay, so let's draw this other one and see what we get. See if we get the mirror image. Because if we get the mirror image across the y equals x line, then we could be assured that this g of x thing here is its inverse as a function. So it's a square root graph that you're familiar with. Remember that? You better. Whips up to the right, right? Okay. Just the top half of a rightward opening parabola. Just the top half, right? And we lift it up 2. So let's go up 2. Oh, I'm feeling good because we're off to a good start. Look at this. 2, 0, 0, 2. And then if you go, let's see, if you go put an x equals 1 in here, x equals 1, you get 3 right there. And so that point would be, let's see, what would that be? That'd be 1, 3, wouldn't it? Let's see, what was this point over here? Down on the parabola's wing. 3, 1, wasn't it? Everything's looking good. And then when we get to put a 4 in here, folks, on your g function, g of 4. G of 4 is 4. It's the same point. So we get the graph looking like this. And so this is, here's our line y equals x. Here's our g of x function. Here's our f of x function. So what would be another name? These look like they're inverses, don't they? Look at that. Don't those points all mirror themselves across this y equals x line? Looking good. So if f of x, if this thing is the inverse, then what symbolism can we use here instead of calling it g of x, something totally new? G of x is f inverse of x. Using this notation. A big part of this course is vocabulary and symbolism. Okay? So here's some vocabulary for you. This is f inverse of x. It means it relates to some other function that happened to have passed a horizontal line test so that the new thing passes a vertical line test.
Now, can we write that vice versa with the g? So g
Yeah.
negative 1.
Sure, yes, we could. So, what if you did not have the pictures? How would you check to see, here's the question, is g of x the inverse function of f of x? There's the question. No picture given to you. Is g of x the inverse function of f of x? No picture provided. You would take and do what? You would see if that apple juice story combined with the cider story gives you back what you started with, right? Or combined with the apple story. Okay, you got the idea. So if you form f of g of x, you better get back x if one's the inverse of the other. So here we go. We're going to take and put in inside the squaring function, we're going to put in square root of x plus 2. Easy. Lose the 2's. 2 minus 2. Square root of x being squared gives you back x. If you do it in reverse, you better get it also. Let's do that. Go inside the square root function On the outside it had 2, and inside there put x minus 2 quantity squared as your input. When you square root a square, you get x minus 2 plus 2 equals x. Any questions? This is a very important process to understand. The math is not hard, is it? Okay. Let me give you one that's a little algebraically tougher, just for the practice. Okay. And we could take any function that we've studied so far. Let me take something that passes a horizontal line test so that I know the inverse will be a function. Okay. Something that passes a horizontal line test. Here's a good one. Let's say f of x is 4 x plus 2 cubed minus 5. We should be able to draw a real quick sketch of that, right? Probably. Okay. This is a tall, skinny cubic. Tall, skinny cubic, 4 times as tall. Shifted 2 to the left. Good, Todd. And careful. You're taking these heights here and subtracting 5 from them. Takes it down 5. If you move it over here with y, y plus 5 would be a shift down. Okay, so this is a shift down of 5. Okay, so a real quick micro sketch of this thing. Tall, skinny cubic, 2 to the left and down 5. Tall and skinny, looking something like that. And if x is 0, I get a positive y-intercept way up there. I'm able to see that. 0 in for x gives me 8. 2 cubed times 4 is 32. Take 5 off of 32, 27. Okay, so it looks like that with its end behavior shown. Got it? Passes a horizontal line test. Here's some weird vocabulary for you, a phrase that I have never understood why they invented it a couple hundred years ago. They call this thing one-to-one. One-to-one what? One what to one what? That doesn't make much sense to me. If you ever hear one-to-one, though, in a math course, what it means is something passes a horizontal line test. 1 to 1. The reason that vocabulary is useful, 1 to 1, it means for one y value, there's only one x value. Okay, it's a shorthand phrase. What that means to us is that if you now form the inverse of this crazy thing, it will be a function. So the result's going to be a function. If it starts out as a cubic, what do you expect to see in the inverse? Cube root. So let's see if we get that. And we only have about a minute or 2 left, so we got to do the math fast. So what do we do to form the inverse? Write down what you're going to do. I'm interchanging x and y. So what I'm going to get then is I'm going to get 4y plus 2 cubed minus 5 has to equal, this was y, now becomes x. Now I need to solve for y. Solve for y. So what I'm going to do is kick the 5 to the other side. I'm going to divide by 4. So I get x plus 5 divided by 4 equals the isolated cubic, y plus 2 cubed. Very quickly, we cube root both sides. Is that all right with people? Cube root both sides to undo the cubing process. We're applying the inverse process, actually, to release what's inside here. We cube root both sides, and we get y plus 2 equals the cube root of x plus 5 over 4. And then we kick the 2 to the other side, and we get an inverse function, which you can now call f inverse of x, and that's going to be equal to this cube root of x plus 5 over 4, and then minus 2 outside of that. I don't have time right now because because of the limits on the recording, but if we took and used our calculator to draw this graph, the original cubic, and we also punched in as a second function this cube root function and set an appropriate viewing window, we should see one graph looking like this, and the other graph should be the mirror image across that y equals x line. My scaling's way off here, you can see on this, but if you set an appropriate scaling, you should see the rolling of this cubic across that line to give you this cube root graph. Okay, that's a few quick examples of creating a function and then how to find an inverse. So we'll see you, I believe, in the classroom tomorrow. Math classroom, I believe, is in our schedule, and we'll do some practice with different things tomorrow. Okay, stay healthy.